watching men's curling live from the Olympics in Pyeongchang.
This is the curling sheet, and the circles are the house. The goal is to get your team's rock closest to the bottom. There are 4 people on each team: the thrower, the sweepers, and the skipper, who's in charge. There are 8 stones which need to be thrown, which means that each person gets to throw 2 stones. They alternate with the other team, so 16 stones are thrown. The last stone thrown is the hammer, which is a major advantage. The ice needs to be prepped before a curling event can occur. The ice is pebbled, which means that water is sprinkled on top of the ice to create little hills and valleys that the rock glides over. This allows for less of the bottom of the rock to come in contact with the ice, which causes less friction.
In the next video, the equation NR equals NF plus MB, where NR is the normal force exerted on the entire bottom of the curling stone. NF is the normal force exerted on the bottom front half of the curling stone, and MB is the resultant normal force exerted on the bottom back half of the curling stone due to contact with the ice.
This equation correlates with this diagram, which depicts the different variables that contribute to the motion and rotation of the curling stone.
But for Sweden, Nicholas Edin coming in as one of the pre-tournament favorites. How about that? That one spot on.
This is a little bit wide.
He didn't like it at all, and that's why he knew it was off.
The curling stone is set in motion. The rotational equilibrium of the plane of the page is the sum of the moments about G, which is the center of mass of the curling stone located on the center line of the stone. This means that the normal force NR must exert a moment in the opposite direction to the moment caused by R, which is the resultant component of friction force exerted on the entire bottom of the curling stone that is acting opposite the direction of motion of the stone. This friction force is due to the contact with ice and acts to slow down the stone as it slides down the ice. Curling is the only sport where the trajectory of the projectile can be influenced after release. In the next video that is about to be shown, watch as the players sweep the ice directly in front of the curling stone to decrease the friction of the stone with the ice.
It is a known fact that contact pressure with ice melts a very thin layer of water on the surface of the ice. This in turn decreases friction, thus the friction is inversely proportional to the amount of contact pressure with the ice. The challenge for curlers is to control the level of the curl of the stone in order to get it to where they want in the target area. They do this by controlling the level of friction of the stone with the ice.
To the curling stone, there is a thin annulus called the running band.
This supports the weight of the stone
and is the part that comes in contact with the ice. It is in the same shape of a ring, about 12 centimeters in diameter. The texture and sharpness of this band's edges influences the friction of the stone with the ice and therefore affects the stone's behavior as it travels down the ice. The curler causes the stone to curve on ice by giving the stone an initial rotation. The rotation of the stone is what causes the stone to curve or curl on the ice as well.
Can he get it? He can! 5 on the board for Team USA. And that is it. The United States has won curling gold at the Olympics.